This is 3.2, day 2. If I asked you to graph this logarithm of base 7, I would recommend you just graph its inverse function first. So just graph 2 points. So let's talk about if I graph y equals, and what would its inverse be? 7 to the x. So if I substitute 0 in for x, I get 1. If I substitute 1 in for x, I get 7. I'll just focus on those two ordered pairs. If it was 0, 1, and 1, 7, what would be its logarithm then? Ordered pairs. Yeah, 1, 0, and 7, 1. And it has all the same domain and range and vertical asymptote that the logarithm of base 4 has. So that's my recommendation when you graph them. Move away from that XY chart, just graph its inverse and then flip-flop those couple points. What if we give you something like this? What are the transformations that are happening in this logarithm? What's the plus 2 inside the function doing? Left 2. You know, I always say think opposite when it's inside. And then what's the plus 3 going to tell me? Up 3. And then what would this tell me? Reflect on the x-axis. So those transformations come back again. We're going to now move on to properties. So 3.3, day 1. Very important formula. We focus on this formula in Algebra 2. Yesterday, we used the graphing calculators or the scientific calculators to evaluate a logarithm that was common log, which is base 10, or natural log, which is base e. Those are the only two buttons that you're able to use on your calculator that has a base 10 or a base e. But what we can do instead, if we have a different base, let's say base 5, is we can convert it to a logarithm of base 10 or base e by using a change of base. So we would use either this equation or this equation. The first one is just in base 10, the second one is base e, natural log. How I remember where to put the fractions is I think about the base, and since it's already kind of below, that's where that value goes. And since this is up higher, this goes up higher. That's the way I remember the order of the numerator and the denominator. What we're going to do next is we're going to do a couple practice problems, so you need to pull out your calculators. Step F will make it around 2 to collect your 3, 1 stuff. Okay. So you can choose either one of these two red box equations on the next slide. I'm going to just do one with common log and one with natural log, just so you can see the difference. You get the same answer. Okay, so we're going to use the change of base formula to evaluate the first example, a logarithm of base 4 of 30. So we'll just do common log to find the answer of that first one. So right now I could not enter in log base 4 of 30. Doesn't work. So I'm going to convert it to common log. So I have a logarithm. Now where does the 4 go? Down below. And where does the 30 go? Up on top. That's the way I remember it. So then you would enter those two logarithms into your calculator. So you'd say log of 30 divided by log of 4. Did you get approximately 2.45344, etc.? Okay. So it's fine for us to just round it to the nearest tens place. Approximately 2.5. Pardon me? Did I say hundredths? Oh, let's do hundredths then. 2.45. Now let's just check it. Let's do common log. So do common log, ln, so natural log of 30 divided by the natural log of 4. Get the same answer? Yep. All right, second example. Let's do natural log. So natural log of the numerator, natural log of the denominator. What's going to go in the denominator?
Log of 32.
And then natural log of, okay. What did you get for an answer? 3.81. We'll skip C. I just did it in case we needed an extra practice problem. All right, properties. Very important properties. They mirror each other, the two boxes. So if you have a logarithm of base A or a natural log, which is base E, they're the same property. So you might want to just write properties of logarithms or common log and natural log. Or you can just write them both down. So here's the first property and what it says. I have a logarithm of some base, could be base 5, could be base 2, doesn't matter. And I want to expand out the logarithm to more logarithms. If there is multiplication going on in that parentheses, I would expand it out through addition. Give you some time to write that down. So it is addition. And we did these in Algebra 2 also. And you do need to memorize them. And they will help us as we move through the chapter to maybe solve equations that have logarithms or evaluate with logarithms. But today we're just going to expand them, and then when we start tomorrow, we'll put them back together and condense them. Here's the second property. If I have division in that parentheses to expand out to separate logarithms, we now have subtracting them. That's the difference, is now it's subtracting them. So if you have division, to undo that, it's subtracting and have two separate logarithms. The third and final property is when you have a power. When you have a power, you can bring that power out in front of the logarithm. So this is a power, you just would pop it down in front. So here's where your y will now be. And then we have 3 examples to work on the next slide.